Okay, paper 2, question 5, and we're going to do part B. If I go to a calculator page, I'm going to define the vectors OG. I'm going to press Control Template to get defined as equal to, and I'm going to type in a vector template. So if I again just press the template key, this vertical template icon there is the one I want to choose, and the vector from O to G is the vector 1. Press tab 1, and to get the third element on the handheld, in the very bottom right hand corner, there's the carriage return button. It's the button to the right of the letter U, and when I press it, I get an extra row like that, and I can type in a 1. And so the vector O to G is the vector 1, 1, 1. We'll press enter and execute that. We're going to do a similar thing for vector CF, and what I can do is I can just press up, up, and press enter, and just go back in and edit this. So I can change the OG to CF, and I can change the middle component, the Y component, to be -1, and execute that. So I have my two vectors. Now I'm going to do the scalar product of these, or the dot product, and going to be setting it up to be equal to the magnitude of vector OG and the magnitude of vector CF and the cos of the angle between them in order to answer this question. Now I'm presuming that this question, well, it doesn't specify whether it wants degrees or radians. Let's just be clear about what our handheld is in at the moment. It's in degree at the moment. So let's go ahead and do the scalar product. So we're going to do menu, matrix and vector. We go all the way down to the vector option, and then dot product. So that long root gives us .dp, and I can press var key to find the two variables which I could use here, and I can just select OG, comma, var, CF. So that will be the scalar product of those two. Now I can just press enter and get a numerical value, and it's equal to 1, and that's come from doing the first component times the first component plus the second times the second plus the third times the third. All right. Now to get the magnitudes of OG and the magnitude of CF, the way we do that is we press menu, matrix and vector, and if we do norms, and the norm of OG, let's just press var and choose OG, and when I press enter, that's the magnitude of vector OG. Similarly, I can press up, paste in, and do the magnitude of CF. So I'll just delete that back, press var CF, press enter, and it turns out these vectors have exactly the same length. So if I want to construct this whole statement, I can just communicate that the dot product of that is equal to the magnitude of OG multiplied by the magnitude of CF multiplied by cos. Let me just show you how you can get that. Press the trig button. If you press the trig button twice and then press enter, the quickest way of getting cos, and we'll just do cos of A being the angle between these. Now when I press enter, I'll get an error because it doesn't know what A is. That's fine, but what I can do is I can now use the numerical solve command, menu, algebra, numerical solve that statement for A, and it will give me a value for A. It turns out to be 70 degrees, which is an acute angle, and so 70.5 degrees would be the answer in degrees to this question. If you needed it in radians, we would simply go to the cog, do document settings, change the angle to radians, choose make default and click OK, and simply re-execute that last command, and I get 1.23 radians. So depending on the context of the question, you could end it like so. We're done.